Okay, hello. It's time for our FRQ of the day. Today we're doing the 2016 number 4 free response questions. So on the AP Stats exam this year, once again, there's just going to be 45 minutes long. It's probably going to be like maybe 3 questions, something like this. It still remains to be seen. But let's see if you can figure out this problem, and then we'll look at the solution together. So let's read this. This one says a company manufactures model rockets that require igniters to launch. Once an igniter is used to launch a rocket, the igniter cannot be reused. Sometimes an igniter fails to operate correctly. The rocket does not launch. The company estimates that the overall failure rate, defined as the percent of all igniters that fail to operate correctly, is 15%. A company engineer develops a new igniter called the superigniter with the intent of lowering the failure rate. To test the performance of the superigniters, the engineer uses the following process. Step 1, one superigniter is selected at random and used in a rocket. Step 2, if the rocket launches, another superigniter is selected at random and used in a rocket. Step 2 is repeated until the process stops. The process stops when a superigniter fails to operate correctly or 32 superigniters have successfully launched rockets, whichever comes first. Assume that the superigniter failures are independent. Part A, if the failure rate of the superigniter is 15%, what is the probability the first 30 superigniters selected using the testing process successfully launch rockets? Part B, given that the first 30 superigniters successfully launch rockets, what's the probability that the first failure occurs on the 31st or 32nd superigniter tested if the failure rate of the superigniters is 15%? And Part C, given that the first 30 superigniters successfully launch rockets, is it reasonable to believe that the failure rate of the superigniters is less than 15%? Explain. So if you want to pause the video and give that a shot, go for it. Okay. So let's talk about the solution to this. And so what we've got here is we've got these superigniters, and so the first thing says is there's a 15% chance of failure. What's the probability that the first 30 superigniters selected using the process successfully launch? Well, the process, or the probability of a success here, is 85%. And so this is saying what's the probability that you're going to have 30 successes, and that is 0.85 to the 30th power. It's 0.85 times 0.85 times 0.85, and you just multiply 0.85 30 times. And the reason you can do that is because it clearly says up here that they're independent. All right, and so that is that. It's 0.85 times 0.85 30 times, and when you do that, you would get a very small number, so it's 0.00763076. Okay, in other words, that's certainly very unlikely to occur if the probability of success is 85%. In other words, the probability of failure is 15%. You're certainly expecting your first one to occur well before that. All right, so Part B. So Part B, we have a conditional thing here. It says, given that the first 30 superigniters successfully launch rockets, what's the probability your first failure occurs on the 31st or the 32nd superigniter if the failure rate is 15%? All right, so there's two possibilities here. You could have, in essence, your first failure, okay, it could be, all right, so we're measuring 31st or 32nd. Remember, and word or in math means plus, and so we're going to add. So it would be the first failures on the 31st one you try, or it's going to be on the 32nd one you try. Now, if you think about this, 31st to 32nd, all right, it doesn't matter, all right, the probability of a failure on the 31st one is still 0.15. Okay, it is still 0.15. It doesn't matter what happens on the first 30 ones. It's just like flipping a coin. You know, it's the probability of getting heads with a fair coin is always 1/2. It doesn't matter if you flipped a coin 10 times and got heads. The probability of getting heads on the 11th one is 1/2. Okay, and it's always 1/2 whenever you flip the coin. According to this, every single time you look at a superigniter, the probability it's going to fail is 15%. It doesn't matter if it has not failed 30 times or 100 times. So that is that. And then, okay, and so or means plus. And so what's the probability that your first failure occurs on the 32nd trial? All right, well, what that means is, it means on the 31st trial, you had to have a success. 0.85, because in this situation, your first failure is on the 32nd trial. And so, and the first failure would be on the 32nd trial, and so that would be 0.15. So that's the probability of success on the first trial, and then a failure on the 32nd trial, all right, which would mean your first failure overall is in the 32nd trial. And so the probability that your first failure is on the 31st or the 32nd trial is that plus that. And so that is going to be 0.15 plus, and that's 0.1275. And that is 0.2775. Okay. And showing your work, by the way, in this, it would be just showing some tabulations here like that, and that would be considered showing your work. Showing your work here is basically showing that. And so don't just put the decimal answer. Show your work. Show this number there, and that would give you full credit there. Okay, and then lastly, it says this. Given that the first superigniter successfully launches, is it reasonable that the failure rate of the superigniters is less than 15%? All right. Well, that probability that the first 30 ones were failures, were successes, that's what you found in Part A. And as we said a second ago, this is telling us it is very unlikely to occur. Okay, and it's certainly in this. This question has the feeling of a p-value. In essence, we're testing this. I mean, we're saying to ourselves, hey, if it is true that you have 85% of success every time, or in other words, 15% failures every time, what's the probability you're going to have 30 straight successes? Well, this is clearly below 0.05 or any reasonable value for alpha. And so basically what you had to say in Part C was you'd have to answer the question. In other words, yes, we do believe it's below 15% because this probability is so small. That'd be a minimal way of saying it. This is the way that I explained it when I answered this problem. You first of all answer the question that's being asked. Yes, it does appear that the probability of failure is less than 0.15. So I said yes. The probability that the first 30 superigniters are all successful, given that the probability of failure is 0.15, is that. That was in essence what we answered in Part A. This is very unlikely, clearly below 0.05. Which is sort of our magic alpha number if we're not given one. It's really below any sort of reasonable value for alpha. All right, so this gives us statistically significant evidence that the probability of superigniter failure is below 0.15. Okay, so there you go. That's your that is your free response question of the day. And so we'll continue to have one of these every day, and then next Monday, April the 6th, we'll talk more about exactly how we're going to grade you for the last 9 weeks and exactly what we're going to set up, which I'm still sort of formulating that. But I really miss seeing you guys, and I look forward to talking to you again soon. Please contact me over Canvas. Please contact me if you have any questions or any needs at all. Please contact me, and I'll be glad to help you out.